this question gives you some information about pollutants. And so it's going to ask 5 questions related to this. And this is going to go a little deeper. So these are all pollutants. And the first question says volatile organic compounds, or VOCs. And sort of the key here is the word organic, are a group of pollutants that are often used as propellants or solvents. The concentration of VOCs is small in the environment, it should say, but they can be very toxic in small doses. Which of the pollutants are not VOCs? So the key here is these are not going to be organic molecules. Well, methylene chloride is an organic molecule, but hydrogen cyanide is not organic, neither is carbon dioxide. This ethyl acetate is an organic molecule, but carbon monoxide isn't, ozone isn't, but tetrachloroethylene is, and so is methyl tert butyl ether. If you look, all of those have the organic molecules, and you should be able to interpret them. This is probably meant to be the trickier one because it's only got chlorines, right? So it doesn't have any hydrogens or oxygens, and sometimes that can throw people off. But there's a list of things that are not organic molecules, and everything else that's going to be containing carbon, we're going to assume is. So we've done question 1. Then it says, design a method to create methylene chloride. So methylene chloride is here, and methylene chloride is CH2Cl2. So I want to make CH2Cl2. So this is going to be dichloromethane would be its IUPAC name. And in order to produce this, I can't make it from an alkene because it's only 1 carbon long. So I can't do an addition. There's no reason for an elimination. It's clearly not esterification. The only reasonable way to do this would be a substitution reaction. And so you'd get chloromethane and hydrogen chloride. And then if I took the chloromethane and reacted it with chlorine, it would make this and another hydrogen chloride. And that would be a reasonable pathway to try to make this molecule. And you'll note that in the question, I did not give you the IUPAC name. So then it says, for 3, draw a polymer that could be made from tetrachloroethylene. Now, tetrachloroethylene is listed here as C2Cl4. So C, and then there are 4 chlorines. So this must be a double bond. So as soon as I see this in polymerization, this is going to be an addition polymer. And addition polymers end up breaking the double bond and just keep adding links after links. So if I've got my chlorine, 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 chlorine from these, and then I add another one onto it, it breaks the double bond, but each carbon has a chlorine. And it'll keep doing that, repeating for as long as you provide more tetrachloroethanes. So that's an addition polymer, and you should be able to spot those both by the product as well as if you've got an alkene and it's a reactant that's likely to become an addition polymer. Then it says, write an isomer of methyl tert butyl ether. So let's make sure we get methyl tert butyl ether. Now, this is a bit of a nightmare, this one, right? So this has got CH3. There are 3 of them bonded to a carbon. So it looks like this, and then OCH3. Now this is called an ether, and we don't study them in Alberta Chem 30. But what I also can see is that this has only got single bonds, and so it's saturated. It has 1, 2, 3, 4, 5 carbons. So the simplest of the isomers for me to come up with would be a pentan-1-ol, right? So if I add up the number of carbons and hydrogen, so sorry, this had a 3, they'll be equal. And I know that because these both have the same number of carbons and they're both saturated and they both have a single bond to an oxygen. If you'd have tried to put a double bond to oxygen, the number of hydrogens will not be equal and they will not be isomers. The second part of that question is describe which molecule is more soluble in water and which molecule should have a higher boiling point. Well, this has a hydroxyl. So that hydroxyl has hydrogen bonding and this does not. So in ether here, this oxygen might add a slight amount of polarity to it, but very little. So this should have low solubility and it should have a lower boiling point than the alcohol that I drew because this does not have a hydroxyl and this does. Then it says draw the molecular structure for ethyl acetate and write its IUPAC name. Then design a reaction that could make ethyl acetate. Well, ethyl acetate is written as CH3COO, and then there's this C2H5. Well, this carbon doesn't have enough bonds, so this is a double bond. And so what I've got here is I've got an ester. And this part of the ester comes from the carboxylic acid. So this is going to be an ethanoate because it's from an ethanoic acid. And then this is coming from a C2H5OH, and that's just ethanol, right? HOCH2CH3. So it's going to be ethyl ethanoate. And if I want to make ethyl ethanoate, if I want this product to be here, then I need an ethanol, so CH3, CH2OH, and HOC, double bond OCH3. And so I'm going to have ethanol and ethanoic acid make ethyl ethanoate.